Hello guys, this is the second lecture for mathematics for physics, and this is on trigonometry. First of all, why is trigonometry important in physics? Physics is about how particle interacts around the world. We live in 3D dimension when x, y, z, and obviously we gotta know some geometry of how these things will operate. Not only there will be algebraic equations, but we're gonna have in certain particle moving in x direction, y direction, and z direction, stuff like that. And so therefore, trigonometry is very important. Sines and cosines, tangents are very important. Also in harmonic motion, such as mass and spring system, sound is oscillations, and waves, such as light is also a wave. So you can analyze with trigonometry. And if you go more higher level physics, you will deal with something called alternative current, which is alternating in sine wave and cosine waves. So it's very important, and actually you can skip this part if you don't want to learn the physics, but every sound is actually the compound of sines and cosines. So you can actually superpose sines and cosines with different frequency and amplitude and make certain sound. So like for example, when you record a video, like sound in recorder, you see this like weird graphs, right? Those are actually could be represented in addition of sines and cosines. That I'm not gonna deal with here. That is too hard to do it. But if you want to know, that's something called Fourier analysis in differential equation. So you can learn that any type of equation can be actually represented in sines and cosines. So that's why sines and cosines are very important, and in physics, very important. Not only we're gonna do with formulas, we're gonna deal with a lot of sines and cosine. Now I'm gonna do some trigonometry. I drew this graph before I start this lecture because I'm bad at drawing. I'm bad at drawing circles. But I thought I found this interesting to show one of the good example to show one of sine and cosine waves is because it's similar thing as this circle rotates, the y value you see this y value. Let's say this is x. Let's say the circle. I hope you can see this. Circle has x component and y component. This one is y component. As it circles down, starting from this position, from 0. But as it rotates around, it goes like with the y value, only this y value rotates around here. So what this represents is over a change of time, at this time, this y increases by this x, and this intersects in here. So this is what one of the good example of sine and cosine. It might be something, why do I have to learn this? It's just one of the good way to like just learn it, and it's just good example. So it rotates like this. So it has a wave like this. And I'll ask you one simple question. What is the length of this circle? length is equal to 2 pi r, right? Actually, I call it 2 pi, but the amount of time it takes to rotate is also 2 pi. And yeah. And then one big rotation will be 2 pi. Right. And then after that, draw a graph like this. So this will be a sine graph. And cosine is similar, how our x changes. Like this. I'll explain this later, why this looks like this. But in the moment, it looks like this that rotates like this. And for x, since it starts from the beginning in here, the x value is very large, as 1 or r, but anyways, you can call it as r or amplitude. Let's say this length is amplitude. And it starts with the amplitude and it rotates around like this. So now here comes for the, actually I want to kind of show this graph at the same time. No, I'll just draw it one more time. Y equals to a sine omega t plus phase. It scares you with omega and like phase, but this is just symbolic notations. Just don't be scared. It's just Greek. It's a Greek notation. Like I think Americans didn't have enough notations to use, so they use some Greek notation. So they call this omega and this is phase. And I'll call this A is amplitude. A is called amplitude. And F, which is, before I draw this, I'll draw one of the sample sine. Let's say this is a sine graph. F1 equals to, as you can see as well, sine of t. This is actually meant to be function, but this is frequency. I don't want you to get confused, so I'll write it as f of t. That's better. F of t, f1. Yeah, let's say it's like this. What is the frequency? The frequency is omega divided by 2 pi. This is also called as cycles over second, or frequency. And they also call it as a period. This is not time, this is period. It's just the exact opposite of it. It's just 1 over f. It's just 2 pi divided by omega, and this is second divided by cycles. And so what this one will represent is that as omega increase, the frequency value will increase. For example, f of 1t is sine of t, and let's say f of 2t is sine of 2t. Then the graph will look something like this. And f of 3t, I'll do this later, f of 2t. And then like this. I should use a different pen. I hope I don't confuse you. But sine of 2t as it increased, as this omega value increased, it became, the frequency increased. So let's calculate the frequency of sine of t. Sine of t is omega value is 1, so it's 1 over 2 pi. But frequency for this one, frequency, and this one is, this is omega over 2 pi, and omega was 2, so 2 pi, so 1 over pi is the frequency. So amount of cycle it increased, it's also increase. And also if the frequency, this omega value decreases, obviously it's going to be more wider, right? The frequency will, as this value decrease, frequency will decrease, right? So the more, if y increases, f, the frequency increases, right? What amplitude will represent is that how large this will be. Let's say f of 3t is 2 sine of t. Then it will look like, what this will represent is that this as amplitude increase, it's gonna more have a wider graph. This is because I'll show you that later, but if you plug in pi over 2 here, when this sine of t is when sine pi over 2, and this at sine pi over 2, this becomes 1, and I'll explain the reason later, but it becomes 2. So amplitude is 2. So U represents a lot of equations, a lot of sine and cosines are represented in this y equals to a sine omega t plus phase. So remember it, it's used in a lot in pendulum motions and mass and spring systems. What is the frequency of the pendulum going left and right and stuff like that. They're gonna ask questions like that. And after this, let's go over some more basics of what's, didn't explain you the definition of sines and cosines, right? So I'll explain you the definitions. Let's draw a circle. Oh, this is a nice circle. Like this. And let's say this is R. And let's say this is an angle like this. An X and Y graph. This will represent X1 or X or Y. Something like this. So let's say there's a point here. Okay. First of all, I'll tell you SOHCAHTOA. Actually, this is angle, right? Sine is X over R. Cosine theta is X over R. Sine over opposite over hypotenuse and tangent over X. Okay, don't get confused. Mathematicians just define this way as is X over R and Y over R is sine and Y over X is tangent. It's nothing more than that. So, like, this is just notation, sine and cosine. Don't get scared. It's just X over R means a cosine omega. So don't get confused. And you can, and X, we call it adjacent. which is this part. X is adjacent, Y is opposite. Respect to this angle, this angle is adjacent. And Y, let's say there's Y, this part is Y, this is opposite, and R is hypotenuse. And yeah, so I hope you guys get this part. And there's a very famous mathematician called Pythagorean, says that x squared plus y squared plus r squared. I won't prove this. I think Pythagorean already proved this. So let's just memorize it for this one. Mostly I want you to purely understand it, but Pythagorean find this fact really well. And using this, I'm just gonna figure out some nice facts of some trig identities. Let's say we divide this by r squared both sides. And we can say this as this and as this. What's x over r? This is cosine omega. Cosine theta squared plus what's y over r? See this? Y over r is sine theta, so it's sine squared theta. This equals to 1. So using Pythagorean theorem, we proved that cosine squared plus sine squared theta is equal to 1. And by the way, before I move to next one, you're gonna solve a lot of like velocity and acceleration, and it has a vector. Vector is the next lecture, but it's gonna have certain direction. Let's say this is r, and these are independent. So just know that. Please don't forget. X is equals to cosine theta r, and y is equal to sine theta r. R multiplied by cosine theta will represent this value, and sine theta multiplied by y will represent this value. This will be used a lot because especially, for example, gravity is only active in y direction, but it does not affect x direction. And because of those facts, like you really have to memorize these equation. And if, for example, if you have like a triangle in a box, and the gravity is acting this way, right? Then if the gravity is 9.8 meter per second square, right? Then the acceleration actually going down this way is just g sine of this omega, right? In y direction. You get this? So you got it could be hard for you, but you gotta have to remember always that even though since the gravity is only going on the y direction, you gotta also calculate how fast it moves towards this way. So next one, this one is longer than I thought. I'm gonna do this. I'm gonna prove some trig identities. Law of sine. We're not only gonna have right angle triangles, right? We're gonna have triangle that looks like, I don't know, this. Can we use laws of cosine and sines or Pythagorean theorem using this? Sadly, no. But there is a way to do this, and this is law of sine. And I want you to truly understand that this works. So I'm gonna prove this how this works really quickly. A, call this B, and let's say this is C. And this one is B, and this one is A, and this one is small c. And there's a one simple trick I can do. It's that you make a line here that is perpendicular to each other. With this one, you can use Pythagorean to figure out some facts. You know that sine of A, and I'll call this as y. I just draw a graph. I'll call this as so opposite divided by hypotenuse, y divided by b, right? And sine of b is equal to opposite divided by hypotenuse, y over a. We have two equations. But what we can do is that y is equal to, if you multiply a on this side, we can plug it in here on y, right? Can you get this part? Right. Because of this, not only we can solve questions in right angles, but because of Pythagoras and this fact, we can use law of sine. So we proved this, so we know that this is always true for any triangles, right? Okay. Proofs are important because I want you to really understand that this actually works, and it always works. And in order to really understand it, you gotta prove it that it should be working, right? Because our calculations always need to be accurate while doing physics, right? Okay. Since we did laws of sine, we gotta do law of cosine, right? Let's say cos. I want you to focus on this one because the proof for this is a little bit harder than the proof for law of sine. Let's make a triangle again. Let's call this B. Let's call this B, and call this big C, capital C. And this will represent angles, right? And opposite will be A, like small. And this will be C. And again, I'm going to draw a line here that is perpendicular because I like Pythagoras. I like Pythagoras, and I want to use a sine and cosine using this. And I'll call this as y, and I'll call this as x1, and I'll call this as x2. And I'll do this really quick. What's cosine of A? Cosine of A is x1 opposite divided by hypotenuse B, right? Then we know that x1 is B cosine of A. But we also know that the c value, this is the length. This is also c. We know that x2 is c minus x1, right? Then we know x1 is b cosine of a, so we know that c minus b cosine of a is x2. Okay, we found out something important, something significant. And then after this, sine of a. What's sine of a? A. This is OA, opposite divided by hypotenuse. Opposite divided by hypotenuse. And this will be represented as also y sine of b. Sine, wow, my bad. Y is b sine of a. But we know that a squared times is equal to x2 squared plus y squared. Pythagorean theorem. So then we know that x2 is equal to c minus b cosine a, and y squared is b sine of a. Then a squared is equal to, what is it done? x2 is equal to c minus b cosine of a square plus y squared is b sine of a square, right? Then yeah, let's do this one by one. So let's see. B cosine of a is c minus b cosine of a is plus b sine of a. Then multiplying this is c squared, c multiplied by minus b cosine multiplied by c is minus 2 bc cosine of a multiplied by minus b multiplied by minus b is plus, because if you multiply minus by minus is plus b squared cosine square of a. And if this one will be b squared minus square a. Right. I want you to see that, you know this, remember this cosine square a plus sine square of a equals to 1? You can factor this out, right? You can factor this out. Can you see this? Can you see this part? Then we can use this fact. Then we can change this as b squared is cosine square a plus sine square of a plus 2bc cosine of a c squared minus, and let's keep going. Then we know that this is 1, so then we know that c squared, and I'm gonna put, since we know that this is 1, if you multiply it by b squared, then if we add it, then it's b squared minus 2bc cosine a. Proved. So So this works according to this A. So we, using Pythagorean theorem, not only right angle triangles, but if you have triangles like this, I don't know, not only right angle it works, but it works with any type of right angle. And just use this formula to find it out. Because not many triangles will be in right angles. And one of the good ways, so we have law of cosine as c squared plus b squared minus 2bc cosine A, and also law of sine that sine of A using these facts, you're gonna figure out, calculate more complex calculations, right? Yeah, I hope you're not too bored. Already 30 minutes past. I don't want you to sleep. I don't want you to be in sleep right now, because this is a summary of trigonometry class. It takes a long time, but this is the last one. So trigonometry, metric identities. So we proved law of sine and law of cosine. And there's a formula called cosine A plus minus B is equal to cosine of A cosine of B minus plus sine of A sine of B. And there's a formula called A plus B equals to sine of A and cosine of B plus minus cosine of A and sine of B. This is one of the Korean ways to memorize it. So for cosine A plus B, we memorize it as kokosasa. Kokosasa. And for sine A plus B, I call it as sa kokosa. Kokosa. That's how I remember it. But that's just one of the examples. For A plus B, it comes from negative, so just remember that it's kokosasa and sakokosa. It's one of the Korean teacher taught me. This one takes too much time to prove, so I'm not gonna prove it. But you can saw in the lecture, but use this as a Bible. This actually proof is actually pretty hard, but let's prove sine of 2a is equal to, you probably saw this, sine of a cosine of a. Number of memorizing it. Let's use this formula. Sine of 2a is equal to sine of a plus a, which is, we use this as differently, but it doesn't mean that b is like different. Just don't get confused. It's sine of a and cosine of a. Right, plus, since this is plus, you use this, and it's cosine of a, sine of a. So we have same thing together. So because of this, we know that it's 2 sine a and cosine a. For this one, for cosine, For cosine 2a, I'm gonna use something different. I might need a extra paper. For cosine 2a, it's a little bit longer, but anyways, for cosine 2a, I'm not gonna call it cosine. I don't want you to get confused. So let's say cosine 2x. Cosine 2x. This one is just same. It's cosine of x plus x, right? And using this formula, we know that there's co-sa-sa, right? Cosine x minus, because it's minus here, sine of x. This is this cosine square of x minus sine square of x. This equals to cosine of 2x. And don't forget to write the sine of 3. Right. And using this fact, according to Pythagorean and how I prove, we know that cosine square x plus sine of square equals to 1. Then we know that cosine square x is equal to 1 minus sine of square x, and sine square of x is 1 minus cosine square of x. And let's plug it in for this part. So we have this formula, and then how will I do this? Yeah, let's say we can also say that cosine 2x is equal to 1 minus sine square x minus sine square of x, right? Then cosine 2x is 1 minus 2 sine of square x, right? Then also using this one, you know that I'm gonna write this one more time. Then we know that this is sine of, we did cosine square, so we have to do this one. So this one is right. You minus 1 here and you add here. So this one becomes you minus here, so it becomes 2. If you do minus to minus, it's addition, so it's cosine square x minus 1. So we figure out that cosine 2x equals to this one, and also, where is it? This one. This one, it's hard to prove and it takes time. And I like to prove these identities. I think proofs are very important for students to really understand that this formula actually makes sense and it works all the time. And just to make sure that every calculation has to be accurate. And in order to make that happen, students need to know that these things work. So proofs are important, and I'm gonna do a lot of proofs, and I hope you didn't want to sleep. Thank you very much, and next one I'll probably do vector, which is a continuous for trigonometry. Thank you very much.